Okay, we have here another integral on the board. I've got the integral of 1 over x squared plus 4 dx. And this idea came from the comments. I can't remember exactly what the comment was, but I know there was a mention of factoring this with complex numbers. And so what I wanted to do with this, instead of using the formula or using trig substitution, what I wanted to do instead was do partial fractions on this. Now to get started with this, before we can do partial fractions, we need to somehow factor this denominator. Well, it's actually not too bad, because what I can do is just write this as x plus 2i times x minus 2i. And you may not be used to factoring it this way. What you can do is if you just multiply it, if you just distribute this out and multiply it back, you'll notice multiplying the x terms, of course, you get x squared. The middle terms are going to cancel, 2ix minus 2ix. Then when you multiply 2i times minus 2i, you're going to get minus 4i squared. But I squared is the same thing as minus 1. So if you look at x squared minus 4 times minus 1, you end up with x plus 4, which is what we started with. So now one more thing before we get to the partial fractions, there's one tool that we're going to need at the end, and I want to just go over that really quick. Okay, we have our complex definition for arctan over here to the right. Now the reason we're going to need this definition later on is because we've introduced complex numbers here when we factored it this way. But I'm not going to derive this formula here. So I did a separate video on deriving how arctan is the same thing as this complex expression to the right. So I'll provide a link in the description to that video. So now we'll continue on with the partial fractions. Okay, now basically for the partial fractions with complex numbers, everything works the same way we're used to. We can use the cover-up method on this, and we've got it set up where we want to find our constant values a and b. So what I'm going to do to start is if I want to make this term 0, I could just plug in minus 2i, plug it in here, cover up this term so we're not dividing by 0. Then this is going to become minus 2i is minus 4i, 1 over minus 4i, so this is going to give me minus 1 over 4i. Then next we'll do the same thing over here for the second term. We'll take 2i, plug it in over here, cover this term up. This is going to give me 4i over here, 1 over 4i, so this is going to be 1/4 i. So now we can just take this and put it back into the integral and continue. Okay, so continuing on from here, we're not too worried that we've got complex numbers in here. We're just going to treat it like we always do. We can still bring these constant values out front of the integral. So then let's start with this one. When I integrate, integral of dx over x plus 2i, that's just going to give me natural log x plus 2i. I'm going to drop the absolute value because we have a complex expression, so the absolute value doesn't mean anything there. And then here we're going to have our 1 over 4i out front, natural log x minus 2i. We have a 1 over 4i in common, so I'll just factor that out front. Because we have two natural log expressions in the minus, I can divide these. I can write this as natural log of x minus 2i over x plus 2i. I can multiply by I over I here just to get the I out of the denominator. This is going to give me a minus 1 in front here. But what I can do is take this minus and use to flip this fraction. So I can rewrite this. I can write it as 1/4 I, and then just flipping it, we're going to end up with x plus 2i over x minus 2i. And now you can see this is actually getting pretty close to our formula over here. This is kind of my goal. This is what we're shooting for. So what I want to do is I want to clean this up and get it to look a little more like this. I'm going to just break out, let's just look at this. So if we have x plus 2i over x minus 2i, if I multiply this by I over 2 in the numerator and denominator, let's just multiply that out. We're going to have I x over 2. Then for the second term, I times I is going to give me minus 1. The 2's are going to cancel here. So this is just going to give me minus 1. Then doing the same thing in the denominator, this is going to give me, again, the same thing, I x over 2. I times I is minus 1, times minus is a plus. The 2's cancel again. This is just going to give me plus 1. But now from here, I'm just going to reverse everything to get it to look more like this. So in the denominator, I'll write this as 1 plus I x over 2 here like this. So this one I'll reverse it, but I need to factor a minus out. So we'll have minus in front, and this is going to become 1 minus I x over 2. So what I can do is take this and put this back in our natural log and continue from there. Now from here, just a couple more steps to clean this up. Now one thing I want to do is get rid of this minus sign. Well, that's actually not too hard. Like if I just, let's just look at this to the side. Now first of all, we're going to have a plus c on here. I didn't write it yet, but we're going to have plus c on the integral. Now let's just look what's going on with the natural log. We've got natural log of minus something. Like let's just call this a. So we can write this as minus 1 times a. But by the properties of log, I can split this up and write it as ln minus 1 plus ln of a. If we have this 1/4 I in front, let's just put that on both sides. This is multiplied by 1/4 I, and this is multiplied by 1/4 I, and we'll keep our plus c over here. we'll end up with 1/4 I natural log minus 1 plus 1/4 I natural log of A plus C. But what's going to happen is this whole piece here, this is a constant value. There's no variable in this at all. So even though this might be a complex number, it doesn't matter. We can still absorb this in the constant. So by absorbing this expression into the constant, that's how I'm going to eliminate this minus right here. Now at this point, I think there's just one more thing I want to do to finish this off. We have this 1/2 in front. Here we have a 1/4. Well, I can write 1/4, of course, as 1/2 times 1/2. We'll have this I, just rewriting everything, 1 minus I x over 2 here, 1 plus I x over 2 plus C. And then the key takeaway is this right here, this is exactly our arctan, except we have x over 2 as our input. So what I'm saying is this whole thing is just arctan of x over 2. So then for our final solution, we have just 1/2 arctan x over 2 plus C, and that's it. Okay, now I have to admit this would have been a much shorter problem if I would just use the formula. I could have just went from here to here and saved myself like 10 minutes. So we'll stop it there. Thanks everyone for watching. Have a good day.